So welcome to this Whale TV broadcast from lockdown. The point of this video is to go a bit further on internal energy and specifically look at an object, a substance being heated up. Could be water in a beaker over Bunsen burner, and see how the internal energy is affected by maybe changes in kinetic energy of the particles in the substance, maybe changes in the potential energy of the particles in the substance over the heating up period, and this could include a change of state. So in front of you on this slide you can see a graph of temperature against time for the substance being heated up. So getting on with it then, the first thing to note clearly is that we have a rule here, and please write it down, so use pause, make some notes in your book. The only factor which can change the kinetic energy store of a substance is its temperature. So if a particle's temperature is going up, what it means is the average kinetic energy of each particle, or of all particles even, is increasing and moving around on average faster, and that is what a change in temperature does. So let's have a look at this. Let's have a look at this temperature graph here. So I've broken it up into three sections. So section 1 is this bit here. Might just shade it in to make it a bit clearer. Section 2 is this bit here. And section 3 is this bit here. So this could be some solid ice being heated up in a Bunsen burner, then reaching 0 degrees here if it was ice, and then you'd see the temperature staying constant for a bit, and then after a while, after the heating's continued, you would see the temperature start to go up again. So let's break it down in terms of what you should know already about changes of state. So firstly, the first section here. So what you've got is you've got the substance as a solid. So in this case it would be ice, and energy is heating is happening and energy is going into the system, and that means that at this stage the temperature is going up. So when the temperature is going up, it must mean the kinetic store is increasing. And when you have a kinetic store that's increasing, it must also lead to an increase in the internal energy store of the substance. So we have an increase in Ke here in section 1, and an increase in an increase in internal energy, an increase in kinetic energy, which leads to an increase in internal energy. What's not really happening is the particle separation isn't increasing. They're still kind of trapped, the molecules and atoms, in a solid lattice, all close to each other and vibrating, and the separation on average isn't really increasing. So we don't have any increase in potential energy there. So on to section number 2. So section number 2, as you can see here, is in our example where we're talking about ice, is you've got to 0 degrees, and 0 degrees is the melting point of ice, or the freezing point if you're going the other way, and you're getting a state change. You're transitioning to water. And what's not happening is the temperature is not increasing. So you're heating it up, and it's quite weird, but the temperature isn't increasing. So that must mean that the kinetic energy store of the substance is not increasing. So that's a really important point to note down. Whenever you have a flat line on this graph, your kinetic store is not increasing, is because the temperature isn't increasing. So I'm going to pause there, and we're going to continue on part 2.